Do you need, Alex, do you need this? Oh, you have it? Okay, this is mine. Okay, now, Alex, I need help. Oh, okay, I got it. Okay, it's all right. I had trouble getting back to this screen. Okay, I got it. Yeah, gotta find the right first page. Okay, we got all this preliminary stuff I gotta get through. Okay, in terms of references, the ones I recommend, the ones we use a lot of references in the notes are from the now discontinued naval manuals, DM7, 7.1, and 7.2. They're still available online. I went on the internet a couple of days ago. If you just type in Design Manual DM 7.1 or DM7, you'll find links where you can find PDF files for both. And 7.1 is on kind of like on soil properties, type of material we covered today. 7.2 is on application, it deals with foundations and things like that. So those are the basic references that I've used. There's also a list of references in the notes, other references. Some of them are a bit old, but still good material. Okay, geotechnical engineering or soil engineering. Today we're going to cover basically the fundamentals of the soil itself. Tomorrow we'll get into foundations, walls, and soil liquefaction, a little bit on earthquake engineering, but you know that's a separate topic also. But we'll cover at least the parts that deal specifically with soil liquefaction, which has been and probably will be covered on the exam, in the basic exam. Okay. We're going to talk about soil classifications. Basically, we have different types of soils. And so it's important to be able to classify the type of soils. Now, we're going to be making a distinction between soil and rock. On the exam, pretty much the emphasis is going to be on soil. And rock, well, you know, we're going to leave that for the geologists. You just need to know that there's rock, and that's the stuff that's much stronger than the soil. But soil, from a perspective of the exam, you know, it will talk about the different types of soils, but basically it treats soil in two basic types, sand and clay. There's a silt in the middle, and then we got gravels and cobbles that are on the coarser side. But in terms of soil behavior, it's going to be basically more sand-like or clay-like. So how do we classify these type of materials? We have these different type of soil classification systems. There's an ASTM, which is kind of now like the general standard, especially ASTM wants it to be the standard since they make money selling standards. There's also one here, there's the AASHTO, which is used by the Federal Highway Administration and some state transportation departments. This is next one here is the U.S. Department of Agriculture. That's not particularly useful for us in engineering purposes. There's one, Civil Aeronautics Administration, generally also not used by engineers. And then the last one here is the Unified Soil Classification System, which was originally developed by the Army Corps of Engineers, and actually is still the underlying basis of what is the ASTM. So probably most of the systems, the ones that you see on the exam, probably would be for Unified Soil Classification System / ASTM, because they're similar, and possibly the second one, which is the AASHTO. AASHTO. Okay. Now you can see here, down at the bottom, shows like particle size in millimeters, and it goes from on the left-hand side, very small particle sizes, to on the right-hand side, very large particle sizes. And so basically for soil, we're dealing with the smallest ones here. You can see on the very end point, 0.001 millimeters, whereas up here on the big side here, we're getting up to where we limit on gravel, maybe where the interfaces with cobbles up to 3. A large difference in sizes. And basically, we're dealing with coarse grain material and fine grain material. So here, based on particle size, and here we see, I'm trying to read this myself, it's hard to read. Here's a number here, it says 200. This corresponds to the sieve size. And a sieve is pretty much, looks like a grid, you see a wire grid. It's what we usually pass the soil through to determine sizes. So it's the number 2 sieve, which